All right, so for number 4, again, there's an x and a y. So if we have x being -1 and y being 0, again, we're going to end up with that indeterminate point, 0 over 0. So there should be nothing at that point, but I do like to bold it just because if it's blank, I feel like I forgot it. And I just want to remind myself, I didn't forget it. It's just, there's not supposed to be anything there. That's like a personal preference thing. You don't have to do that, but there's not going to be a slope at that point. All right, so again, we can knock out some of these. Everywhere else that x is -1, so for this entire column, your numerator is going to be 0. -1 plus 1 would give you 0. So those are all going to be 0 slopes. And then everywhere else that y is 0, so this entire row right here on the x-axis is going to give you a 0 denominator. So those are going to be undefined slopes. So you can knock out a bunch of them, at once. And then just like we had some reflection in the previous problem, everything that's up here is going to reflect down here. Y is positive for these points up here, and then y is negative for these points down here. So if y is positive up here, these are going to be positive slopes. Down here, they'll be negative. So once I do these ones, I can just reflect them down. So we do have to go point by point, but you can kind of just do half of it. All right, so here we go. This is the point -2, +2. So if we put in -2 for x, that'll be -1. If we put in 2 for y, that'll be 1/4. So -1/4. So very, very not steep at all. All right, here we have the point -2, 1. So if x is -2, our numerator is negative. Wait, I'm sorry. Brain just shut off there for a second. X is -2. Okay, so our numerator will be -1. And then if y is 1, that'll be -1/2. So a little bit more steep. This is -1/4, so -1/2. So a little bit more than that, but not much. All right, and then -2. Oh, I already did that one. That's undefined. All right, next point, we have 0, 2. So if x is 0 and y is 2, we're going to have +1/4. So the same slope except positive. And so actually the same thing is going to happen here. This would be slightly more steep. It's hard to tell the difference between 1/4 and 1/2. All right, this point is 1, 2. So if we have x is 1, y is 2, we're going to have 2/4 be 1/2. And then here we have 1, 1. So that's going to be 2 over 2, which would be 1. So that's even more steep a little bit. 1 is the steepest one we've done so far because these are all 1/4 and 1/2 here. All right, and then we've got 2, 2. So if we plug in 2, we get 3/4. So I don't know, about like that. Somewhere in between the steepness of these two. And then 2, 1. So that would be 3/2. So that's even steeper than 1/2. So the steepest one we've done so far. And then again, all of those are going to reflect down here. Again, it isn't perfect. These aren't perfect. It's just, this one should be steeper than that one kind of thing. It's just the best you can. It's not going to be absolutely perfect. And I'm just taking these and reflecting them down here. So something like that. Good enough. You don't have to be a fantastic artist. Just take those and do the mirror image down here. All right, so description of what these look like. These are going to be hyperbolas. And they used to teach this in Algebra 2, many years ago. And then they took it out of the curriculum, which was really frustrating. A hyperbola is a graph that does something like this. And it looks like I drew 2 graphs there, but this constitutes one hyperbola. And it could also go this way. They're neat. They're really cool graphs. It's not a function. It doesn't, pass the vertical line test. But those are hyperbolas. And that's what this would be. You'd have part of it up here and part of it down here. Now, when we do the general solution, we're going to have a plus minus. When we do the particular one, you're only going to get 1/2 of this. All right. So that's what a hyperbola is. And so you don't get a slope at that center point there. All right, so these are hyperbolas, which I wish we still taught. centered at, what is that, -1, 0. So hyperbola is centered at -1, 0. So let's go ahead and solve this. We're going to multiply over the 2y, multiply over the dx. So it's like cross multiplication. And again, this is just like what we went over in the homework. So this antiderivative is y squared. And then over here, we're going to have 1/2 x squared plus x plus c. And then to get y by itself, we're going to square root. And because it's the general solution, I'm going to put the plus and the minus. So that was not too bad. All right, now particular solution, we're going to plug in -1 for x, +1 for y, and see what we get for our constant values. So x is -1. Again, you want to go back to right after you did the integration, before you started, solving for y. So we're going to plug in -1 for x. That would make this 1/2 minus 1. So it would be -1/2 plus c. And then y is 1, 1 squared is 1. So solving for c, that would give us 1/2 or 3/2, however you want to write that. You write 1.5, I suppose, if you want, right? 1.5 or 3/2 for c. So I'm going to rewrite this step and just put the 3/2 in there for c. And then we're going to solve for y. Now we're making the decision, do we want the plus or do we want the minus? And our initial condition, it's based on the y value, the output of that. I realize the x is negative, but you base it on the output. The output is positive, so we want the positive square root. And then when you go to draw that in, all you have to do is start at this point, -1, 1. So that is right here. So here's -1, 1. And then you just flow along with these slopes. And you shouldn't run into any of the others. You just kind of like go in between them. And just, again, make sure you go all the way to the edges. And again, the full hyperbola would have another part down here. But again, for the particular solution, just choosing, do we want the plus or the minus? So something like that. And again, it's not perfect. I'm not like a perfect artist. Good enough. All right, and then last one. I'm ending on an easier one. This one only has x's. All right, so let me throw a question at you. Since there's only an x in this, will all of my rows be the same or will all of my columns be the same? You can just type rows or columns. Which can I do if I just have x? And good, yeah, you can abbreviate. I have some people abbreviating it. Good, columns. So all the columns we can do at once. So it's really nice if you have just an x or just a y. All right, so for this first column, all of the x's are -2. So -2 squared would be 4 times 3 is 12. Okay, a slope of 12 is going to be like practically vertical. Very, very steep. All right, if x is -1, we're going to get a slope of 3. So not quite as steep as 12. Again, they're not perfect. It's just if that one's 12 and that one's 3, this needs to be steeper than this. All you're doing there. All right, for this entire column, x is 0. So all of those are going to be 0. And there is one here. Sorry, it's just it's on the axis. All right, and then where x is 1, we get 3 again. So just make these look the same as these ones. And then for 2, again, you get 12. So just make those look the same as what you had over there. So if we were to describe these, let me just throw the question at you guys. You can type it to me privately. I just want to see what you guys give me back. What are these going to look like? If you were to, draw in and follow along with those slopes, like kind of just follow what they're doing, what is this graph going to look like? Or you could think about solving this because we're about to do that in just a second here. But what are we going to end up with? Good, I'm getting a couple of answers there. Anybody else want to say anything? Let's solve it. and then we'll see what we get. All right, since all there is an x, all we have to do is multiply over the dx. And so this left side's just going to be y equals. And so this antiderivative would be x cubed plus c. So yeah, they're going to be cubic graphs. So if you like follow along with these, you're going to get like a wiggly kind of thing. And that's cool. I want you to just make a connection between that. Some people writing me privately, that's nice. Because when you solve it, that's what the graph that you get looks like. So one particular solution, we're going to plug in 0 for x, 1 for y. If you plug in 0 for x and 1 for y, you are going to get that c is 1. So it's going to be y equals x cubed plus 1. And so all you have to do is start at that point, 0, 1, and then just, follow along with the slopes here. And again, it doesn't have to be perfect. I'm not like fantastic at drawing these, but good enough. You don't want to run into any of the other ones. You just want to kind of follow them, and you want to go all the way to the edge of the graph.